Okay, this is the demonstration for assignment 5 real-time rendering. And basically, I choose the paper dynamically reparameterized light fields. And the light field is used a set of a light field renderer is used a set of images to generate a virtual scene rendered by those images. And to generate a light field, we need a set of images. Here we open the set of images by opening this config file. And the config file, you can see that it is loading the images. The config file specifies some camera parameters for the captured image set. And based on those camera parameters, we can calculate the light field. And we can also calculate some other parameters that are used to calculate the light field, for example, image distance and aperture diameter. Here, after it calculating the scene, you can use keyboard to control the virtual camera in this virtual scene. And you can see that this scene are created using the multiple images, and you can only move around in this small area because the images using user images are limited. Okay, so now the exposure is just a parameter that controls the light of this scene when rendering. And the render size is automatically detected by the images you opening. And here the optical parameters are controlling the original data camera and the virtual camera's parameters, virtual camera's settings. Here the focal lengths are the virtual camera's focal lengths that can control how far it is focusing on this scene. That is the virtual camera you can control. And the sensor wise also are controlling the virtual camera that you are moving to focus on certain area of images. It is basically adjusting the captured image size, virtual image size. And the focus distance is the virtual camera's focus distance, and it can control the focal plane of this virtual camera. You can see that when you change the focus distance closer, for example here, it will focus more on closer objects such as the metal head. And when you change the focus distance larger, it will focus more behind the object. It will focus more further away, like the wall behind. Here, f-stop is a parameter that controls the aperture settings that can control the size of aperture. If f-stop is larger, the size of aperture is smaller. And you can see that due to this scene is generated using multiple images captured by multiple cameras. When I change the f-stop larger to make the aperture smaller, fewer lights will come through each data camera, and it will cause those circles, cause those images to be circles. And the filter for off is just a parameter that controls the ambiguous area that controls the interpolation between those area that the camera is not focusing on, to make it more obvious or not, or less obvious. And also you can enable the focus breathing and the normalize aperture to normalize the light coming from each data camera to make the scene more to let the scene more realized. And also the autofocus mode, you can press shift and click on the objects in the scene, and it will autofocus on different parts of the scene. And here, this method is using template matching and sum of the square difference to match those two images to decide which of the two selected data camera are used to automatically detecting the focus distance, recalculating the focus distance. You can see that the focus distance is recalculated based on the two data cameras here, so that it will automatically focus on certain area in the scene. Here, this scene is generated using a set of different parameters camera data, so that here the light step isn't used because it uses dynamically dynamically reparameterized light fields instead of the old method of light slab parameterization. Okay, this is okay. I will give the reference for the scene used. The scene is created by those two people, and here I use this scene to generate the light field. This is the end of the demonstration. Thank you.